Hello, everybody. Thank you for joining us today. We appreciate your time. Let's go ahead and get started. Welcome to Navigating the Hidden Lifecycle Costs of CNG. We're excited to share this important information with you today because we know that it's critical for you to have the most successful CNG implementation possible, whether you're just beginning your business case for CNG implementation or simply just looking for ways to improve CNG service station maintenance and to reduce operating costs. My name is JoLynn Kennedy. I'm the Product Marketing Manager at Broadwind Energy, and I'll be your host today. I'd like to encourage you to visit our website frequently. We do have a whole host of resources for you in terms of CNG information. We have on-demand webinars available. This webinar will be found on our website. We have case studies, white papers, brochures, a whole host of information for your knowledge when you are looking for key information in terms of CNG. So please feel free to check our website at www.bwin.com, and also feel free to reach out to me. My email's on the screen, jolynnKennedy@bwin.com. Let's go ahead and get started. I'm pleased today to introduce to you our expert panel speakers. Joseph Reisinger is our VP of Product Management at Broadwind Energy, and Joe brings 15 years of experience in the nuclear, gas, and steam power generation and capital finance markets. He began his career at GE pursuing diverse roles that included regional and international responsibilities, acquisition, integration, and divestiture planning. Joe is a graduate of the Massachusetts Maritime Academy. He also is a certified Six Sigma Green Belt. And Joe was brought into Broadwind as the Director of Environmental Health Services to transform the company's performance around environmental health and safety. In 2013, he was appointed VP of Product Management to diversify and grow the company's product and service offerings and lead strategic planning, business development, marketing, and sales initiatives. And today, Joe leads Broadwind's expansion into the CNG market. Dave Postuma is the Director of Sales for our CNG division at Broadwind. He's a seasoned CNG expert and has been in the natural gas vehicle sector for over 20 years and has worked for industry-leading companies such as Washington Natural Gas, IMW Industries, and Clean Energy. Dave has held diverse roles including NGV marketing representative, equipment salesperson, sales engineer, and manager of NGV product development. He's been involved with the specification, design and project development and management of over 200 CNG and LNG fueling stations nationwide. And we're excited to have Stephen Roos, the Director of Engineering at SAFE North America. Stephen brings engineering expertise from a nationwide portfolio of CNG projects at Mansfield Gas Equipment Systems and Clean Energy Fuels. Mr. Roos is a registered professional engineer in mechanical engineering and has experience with a wide range of CNG equipment used in the North American market. So we're excited to have these expert panel speakers with us today. And at this point, I'm going to hand the podium over to Joe Reisinger. Go ahead, Joe.
Great. Thank you, JoLynn, and appreciate everybody joining to take some time out of their schedule to learn more about Broadwind and SAFE and the offerings that we have to bring to the North American market. So to kick things off, initially I want to talk a little bit about the strategic partnership between our two companies. We are new to the North American market, so I think it would be helpful to provide a little background there. What we will spend the majority of our time on this afternoon or this morning, depending on where you're joining from, is to discuss 5 hidden costs of CNG and some of the ways that we believe are available to address and mitigate some of the costs that you may foresee and be tackling as you look to deploy CNG fleets. So to talk a little bit about Broadwind and SAFE, the partnership was really established to benefit the core competencies of our respective companies. So to focus in first on SAFE, I did mention that we're new to the North American market, but I think it's important to recognize that SAFE has a very long history in the natural gas vehicle market. The company has been involved for over 40 years throughout the world. They have units in operation across 44 countries, and the experience that they have built over this time is really what we're looking to bring into the North American market and advance the development here within the region. So a robust engineering team and product design, which we'll talk a little bit further about. What I wanted to zoom in a little bit on is the 3,500 installations that they have worldwide. So just to kind of define things, I think oftentimes we hear that in the international market, stations tend to be perhaps on the smaller side because they're used in fueling vehicles that are perhaps personal vehicles as opposed to commercial applications. And I want to share this image here of a SAFE installation in the European market. It's used in a public transit, so you can get the idea that these facilities are really of the scale that you tend to see here in the North American market. On the left-hand banner, there's also two large fast fill stations that are used for commercial operation. And so when you step back and think about it, at 3,500 operating units, that's more than double the installed base here in North America. So we really bring to bear a lot of expertise in the market that we have to share with you all. And then if we move on to Broadwind, what Broadwind really brings to the table is the ability to localize the packaging of the product here and be able to support post-sale service as well as parts over time. So Broadwind is a diversified manufacturing company. We primarily serve the energy market, and we have a keen interest on supporting product lines that promote cleaner energy production. We do have a facility in Texas where we will be packaging the units, and we have a service network that spans pretty well across the country, and we have the ability through our existing footprint of facilities in multiple places through the country to be able to support same or next day parts delivery. So moving into really the meat of what we wanted to cover today, there's 5 elements that we'll talk through, and bear in mind that as an equipment OEM and packager, we're really focusing on aspects that have an impact on infrastructure. So I will cover the first on oil carryover and then pass to my colleagues to cover the balance of topics. So when we think about oil carryover is an important aspect for a natural gas vehicle. Really inherently, natural gas burns much cleaner than say, diesel or an oil-based fuel. And so therefore, the engine is designed to be oil-free in the vehicle. And so therefore, if you have oil that is carried over from the compressor into the engine, it can be very problematic. And I pulled this clip from Leo Thompson at the Natural Gas Vehicle Institute as a very succinct point here that as we think about building out infrastructure, we really need to be mindful of that potential for oil carryover. So how do we address that? Really, in today's market, I think there are good programs in place to address the potential for oil contamination, but recognize that these are programs that require perhaps additional costs in the form of post-filtration on the compressor, as well as the potential for a human error if the system is not maintained in accordance with the program guidelines. So what SAFE is bringing to market is a non-lubricated system. So what that means is that there's not zero lubrication, but it means that there's no oil that is introduced or forced into the cylinder heads of the compression stage, thereby significantly reducing the potential for oil carryover into the vehicle. why we're able to do this is when you step back and think about the history of compressors and the equipment that's typically found in the market today, the genesis is really driven from the oil and gas market. And in the oil and gas market, when you're talking about perhaps systems that are used for pipeline transmission and other boosting applications, the risk or the potential for oil carryover to enter that gas stream is really immaterial and not a problem for the end users. But in the scenario of a natural gas vehicle, it's very important that that gas stream is very clean and does not have any oil that is carried through. So when you think about SAFE, a company that's been in the natural gas vehicle market for 40 years and has built their product from ground up specifically for use in a natural gas vehicle application, they've really thought about building that design in a different light. And the end result is a system that really reduces that potential because, again, there's no oil that's force lubricated into the cylinder heads. So with that, I'm going to pass it off to my colleague Dave to pick up on the next topic.
Thank you, Joe. I'll discuss the next couple of items here: station construction and operating costs. Starting with construction, when we look at the costs of building stations from a equipment manufacturer's point of view, there's some parts of the construction that are not really well controlled because they're out of your hands. They're in the hands of the contractors and the bids that you get. But there are some things you can do in the design and equipment choices which are very controllable and can allow you to minimize the cost of building your station. So engineering, equipment layouts, and also very importantly their interconnections are something that you can think about in your early process that will allow you to reduce your construction costs. If you've got a lot of piping and a lot of tubing and electrical runs, you're going to increase your costs. So when you can reduce them through your equipment design, you can take out a lot of that underground work. This can affect not just the cost of the tubing and the piping, but also the compound sizing and even the number of contractors you have that are out there working, and have them out there working sometimes at cross purposes. And lastly, the less that you have out there in the way of in-ground and interconnection, the easier it is to get through the inspection and approval process. Also, you can get into some issues with just time. Time is money, and the longer the construction process goes, the more this construction is going to cost. Having multiple equipment suppliers and the potential individual delays that each one may or may not have, each one having their own logistics, and if you've got, for example, 4 separate main components that you're putting together, each of them needing a crane, you've got 4 potential points where a delay could impact you and say double the cost of crane work. Also, the more complex your station design is, the more people you're going to have out there working. Your critical path can get extended, and one example might be the priority panel. If you've got that remotely mounted, you have piping runs to it, you have conduit runs to it, electrical. So you have multiple contractors and multiple people working on this versus maybe having it on the skid. So the engineering of the project is going to be the beginning component, and something definitely worth looking at. Last issue that I'd want to bring up that can be a problem is the startup. And the more complex your station, the more components you have by different suppliers, the more commissioning people you'll have out there, and the more problems you run into if one of them has an issue. So, what are some ways to deal with these problems? A common solution that sometimes is passed over, but is very effective, is to single source your equipment. If you have your design and your interconnections all being managed by one supplier, then you eliminate that source of pain from your critical path. It also can allow you to better manage your delivery schedules by having one supplier with one logistics provider and having them ensure everything arrives on time, preferably at the same time if that's what you're looking for. Another solution is to limit the number of contractors. If you have multiple general contractors on a site, you are guaranteed to have some sort of problem. It's happened on every project that I know of where there are multiple contractors with main responsibilities, and you end up with not having a single person that you can deal with for problems and maintaining schedule. I think the biggest thing you can do to minimize your on-site construction costs is to simply minimize the amount of equipment that you're installing. So I'm not saying eliminate a dryer, but I'm saying maybe look at how you could put fewer components in. So I know one thing to look at is having your controls on the skip and having the priority panel on the skip. And this can significantly reduce a huge amount of wiring and tubing that is all typically done in the field and subject to all the problems that can occur with that. And it reduces not only site work, but also all of the testing and commissioning and termination and inspection work that would go with those connections that you now are doing in the field, as opposed to having them done at the factory and tested and going through a commissioning there. So that's a great way to get rid of a lot of cost in the construction side. So moving on to the operating costs, there's a few problems that people come across that they don't really have any control over, but again, there's some that you do. One of the most common problems is that people can oversize their compression and end up with either a very large compressor or a couple of too large compressors, and they aren't really thinking through the demand costs, the demand charges that can be associated with large electric motors. Another item is the routine service that goes with operating a lubricated compressor. You have a large amount of oil that you are injecting by design into a lubricated cylinder, and then a large amount of oil that you are attempting to absolutely filter 100% of it back out. And then what do? Now that you've had to manage adding the oil, filtering the oil, now you got to do something with the oil after you've filtered it off, so you have to deal with that as a hazardous waste. This can add up to a tremendous amount of labor and consumables, such as the filters. And over the course of the lifetime of the station, you are you're looking at a significant amount of money. A large station could run into $100,000 over 10 years just in oil and filtration costs. And this doesn't even take into account what Joe said previously, which is that you're at some risk in that this is being managed by personnel of maybe going through a change in maintenance people or a missed maintenance scheduled item, and accidentally something happens and you get oil into a vehicle or a group of vehicles, and the risk and costs that can go with that. So let's see, one other item here: unscheduled maintenance is due to material or material fatigue or wear, in that you don't catch, can result in significant loss of equipment operating time and revenue. So when you are looking at your maintenance and you're looking at your quality of equipment, you have to make sure that you have a strong maintenance schedule in place that is adhered to, and that also you are using the best equipment that you can to ensure the least amount of downtime and lost revenue. So how do you look at these issues and deal with them in your design? When you're looking at the overall station capacity and you're looking at the size of your compressors, I think it's definitely worth looking at smaller compression that can get the job done. So you're looking at your storage, you're looking at future growth and how you can manage that with a minimum cost, and you're looking at just keeping a optimum size in your motors to ensure that you don't run into excessive demand charges any more than you need to. And so if you can keep your main motors to the smallest size possible, that still can deliver you the fuel you need in a given demand period. That's going to be key to keeping your operating costs down on a monthly basis. And demand charges they're significant. They're there every month, and they run into thousands and thousands of dollars. One thing you can do to help you in your sizing would be to look at the growth of a station and how you can meet that growth without oversizing your initial design, and that's to have other tools ready, which would be something like a hydraulic compressor, which could be used to augment a peak demand period, and that will keep your overall horsepower of your system down. And again, this goes back to your monthly demand charges and keeping them down to a minimum. The equipment design and going back to the quality of the equipment, I would definitely look at a non-lube compressor. There's ours is, and we're not the only ones, but it's definitely a major plus to look at controlling your oil carryover from both a risk standpoint of fleet contamination, but also just from a cost standpoint. And if you can keep your oil consumption down, that means that at $50 a gallon, you can use a lot less of it. If you're not putting it into the compression and you're not taking it back out, your filters aren't being worn out as often. While we have filters on our system to act as insurance and to manage any potential possible boundary lubrication, the fact that they're being used so lightly means that they last a lot longer in a non-lube capacity. I would also look at the remote monitoring capabilities of your compressor as a way to help you with diagnostics. If you can monitor and measure the outputs of the gas temperatures and the gas volumes, and keep an eye on the maintenance needs of the compressor. You can keep your maintenance in the scheduled windows, and even if it's maybe not in a scheduled window, but if you're tracking it and you can manage a repair rather than having to deal with it as an emergency call out, that kind of trending data is critical. So I would look at a compressor that is featured in such a way that it can measure vibration and trend that it can measure temperatures and pressures and trend that. Something that has the capacity to remotely manage all of that and see that on a periodic basis, so that you can use that data to help you maintain as low as possible maintenance costs. And that's something that you would look at in your equipment, specify it or design it. So find a quality piece of equipment that has those features and that can help you keep those costs down. With that, I will let Stephen address the next issue there of fill times at organizations.
Hi, this is Stephen Roos with SAFE North America, and I'll take over here at fill times at stations with increasing demand. So obviously the problem we want to have in these facilities is growth. We want the fueling consumption to go up. We want to be able to deliver more fuels to our clients, and that can often be a really good problem to have, but it's a problem nonetheless. So due to limitations in station infrastructure, when you're putting in a facility, you hope to draw everybody from that area and bring in additional clients. And as that grows, you may not have anticipated that level of demand in your facility. And what you'll find is most fast fill scenarios will use a 3-bank storage system or a cascade type storage system, and that's only going to be able to deliver about 30% of the usable volume to the client vehicles. So you have an issue of either putting in more storage. It's not always practical. Same with additional compression. So this can be a really limiting factor in the delivery of fuel to your clients, and ultimately the amount of revenue you can generate from your facility. So there's a few different solutions that you can bring into play here. And obviously the first is to simply add additional storage. If you have the ability, if you have the space, you're going to get, again, about a 30% capacity. So if you add an additional 3 banks, whether they're cylinders, whether they're spheres, you're going to add maybe 90 gallons of capacity. But you're going to spend about $100,000 plus installation for that capacity. And so it can be a pretty costly option for what you get. Similarly, you can add additional compression, and if you've already designed your facility for this, it might not be a big challenge, but again, you're going to have limitations due to space. You can often run into trouble with electricity availability, peak demand charges, as Dave mentioned. You're going to be looking at more than the cost of $100,000 in storage to add an additional reciprocating compressor, especially when you consider most installation costs, especially if you need facility upgrades, electrical service. It can be significantly more expensive to add additional compression. You do get more deliverable volume over the 24-hour period, so if you have a constant demand that is just totally exceeded your compression capabilities, that may be your real only option. But for most people, it's just simply they get those peaks, those really big influxes of people, sometimes in the morning, sometimes in the evening, where it just totally takes out everything you have in storage, and everything you deliver from there on is straight from the compressor. If you'd like to avoid that kind of scenario, we actually have, there's a hydraulic compressor which can deliver up to 19 GGEs per minute, and that's actually compressing from storage straight to your vehicles. And through that, you end up utilizing about 90% of the gas that's already been compressed into storage. So it doesn't increase your footprint significantly. The hydraulic compressor is very compact. Electric demands are relatively small. We have options up to 100 horsepower, and this will allow you to get through those peaks utilizing the existing compression, existing storage, and allowing your existing facility to replenish that storage after that peak has passed. So this can be, and the cost is similar to an additional set of storage vessels. So the hydraulic compressor can be a very good option for scenarios where this peak demand has just exceeded design limits. And then, as we touched on, there's certainly limited infrastructure available in CNG, and that's what you hope to draw people to your facility for. But at the same time, that also can be an Achilles heel in that if you're the only location there, you need to make sure that you're reliable. And so you'll have, oftentimes the solution for that is to build even 50% or 100% extra capacity into the facility, even from the start. And that can be a very, very costly proposal, because that increases all the costs that were described earlier: operating, installation, just ongoing maintenance expenses. But you're basically left without much of a choice if you're expected to be able to operate this facility nonstop with no downtime. And so there are, again, a few solutions that can help mitigate this. And so obviously, a design that offers full redundancy allows a piece of equipment to go down for maintenance and still be able to deliver your demand without any interruption. And that's obviously the ideal solution, but it's also the most capital intensive. And so if you're looking for something that's a little less capital intensive, you can either, if you're in an area that is, say, Southern California or some area that's already fairly well developed, you can also work out a partnership with other facilities in the near area and utilize their equipment for not necessarily an immediate backup, but a remote backup type solution. And if your operations will allow for it, that can be a good low-cost solution. Ultimately, though, most fleet operators want to have that redundancy in their control, and a good solution for that is a mobile fueling option. And SAFE CNG Fuel Link will give you the ability to have a mobile compression solution, so you can deploy this mobile compressor to a facility if it has unscheduled downtime or scheduled maintenance, or even if you just need to reach out to a satellite facility that doesn't necessarily have the infrastructure there yet. There are options to provide storage on board that will permit basically a wet hosing type operation for CNG. And so you can use this unit as a standby backup. So say you have multiple facilities in a region, but you don't want to necessarily put double the compression at every one. You could have a mobile or two that you keep in a central location ready to deploy in the event of a failure, or you just rotate it in during normal maintenance operations. And it can also be used to supply a smaller fleet that doesn't have the need to have its own freestanding CNG compression facility. You can potentially acquire a mobile unit like this, either compressed from pipeline gas, or visit a local facility where they can act as a mother station, load you up, and then you dispense to your vehicles at your local facility. So all of these can be, there's a lot of flexibility that you get having this mobile compression solution at your fingertips.
Great, thank you, Stephen, and thank you, Dave, as well for your input. Just as we close things out, I wanted to take a moment here and just highlight that, while Broadwind Safe is focused primarily around the compression element associated with CNG infrastructure, that we do have relationships across the value chain, and we're able to offer through our partnerships and relationships the ability to offer more of a turnkey solution to clients that may have an interest in that route. So if your project is such that you would like to have the dryer, the compressor, as well as the dispenser all offered in one bundle, we have the ability to do that. We also, through relationships with companies that are involved in building out stations on the civil and design side, we can offer those elements as well, either indirectly or through a bundled offering through Broadwind. So I would encourage anybody that's interested in learning more about our product offerings to visit our website at bwen.com. And at this time, I'll turn it back over to Jolynn to summarize and close out before moving into a couple of Q&A elements that we've commonly come across with our clients.
Great. Thanks, Joe and David and Stephen, for sharing your insights with us today and your great presentations. We appreciated it. This concludes the speaking portion of our webinar today. And as Joe stated, we will move into the Q&A in a moment. I'm going to quickly summarize what we talked about. Today, we talked to you about assessing the hidden costs associated with the development and maintenance of CNG stations. These strategies are key to ensuring a successful and profitable CNG implementation for your organization. Some of the common benefits are CNG can help reduce cost, emissions, and dependency on foreign diesel fuel. CNG also helps reduce fleet vehicle maintenance. It can maximize your vehicle performance. It extends your engine life cycle and also increases safety, which is vital. It's very important. Working with Broadwind Safe leverages the experience of a worldwide leader with over 3,500 CNG compression packages installed to ensure the success of your CNG project. We want to help you be successful, and we will do that by helping you reduce compression package and storage capital costs, minimize installation complexity, and improve your fueling time for your end customer, which is very vital. Finally, working with Safe, Broadwind Safe, we are part of the Landi Renzo family, and many of you may be familiar with the Landi Renzo brand. They're a worldwide leader in alternative fuels. That concludes the presentation of our webinar and what we talked about today. I'd like to, before I start the Q&A, I'd like to remind you we will be hosting a webinar on virtual fueling stations in the month of November. So please be sure to look back at our website, and we will be reaching out to you to let you know when the date is, but we are planning it for November. So we hope you join us for that webinar. Okay, let's go ahead, and we're going to get started with questions. Can the CNG Boost hydraulic unit be used and integrated into an existing fueling station that is non-Broadwind Safe?
Jolynn, this is Joe. I'll take that first question. The hydraulic unit can be integrated into existing infrastructure. So to the extent that perhaps you have an existing station that may have non-Safe OEM equipment, we can integrate and offer that product line to for you to deploy.
Great, thank you. Here's another one. What's the largest and smallest reciprocating unit available from Broadwind Safe? Dave, maybe you can take that.
Yeah, absolutely. The range of Safe compression that Broadwind is currently packaging is from 100 horsepower up to 600 horsepower, and although Safe has a slightly broader line than that, that's where we're at right now. We are evaluating some of the other compressors, and in the future we may even offer more. But for right now, 100 to 600 horsepower, and through the SAFE partnership with GE, they have packaged up 2, 3, 5,000 horsepower. So in the oil and gas patch, we can work with them to supply even larger units. But for the NGV business, 100 to 600 horsepower.
Great, thank you. How do you monitor the equipment? Stephen, can you help us with that?
Of course. So the monitoring that we have actually comes standard on every unit, and there's actually a web interface that you can access remotely. All you need to do is provide network access to the unit, to the control panel of the unit, and it actually integrates right into the HMI. And that allows you to view the current status of the machine, all the pertinent operating parameters, and even do trending and charts on all those key parameters, so you can see how the machine has been operating over its life. And so that can really allow you to monitor the condition as well as observe the unit for potential maintenance that may be upcoming.
Great, thanks, Stephen. What is included in your mobile unit?
Jillian, this is Joe. I'll take that question. The mobile unit is offered standard mounted on a trailer that can be integrated into either a local utility line or fed by external storage that can be trailer mounted. And we also offer the product with a integrated storage system solution on board, so it can be completely independent of any external sources, both from a power and gas perspective.
Great, thank you. Here's another question. How does the SAFE compressor handle vibration?
Jolene, I think I can handle that. So the SAFE compressor, first of all, is a mechanically balanced design. So vibration is minimized already, but what vibration does occur and is naturally occurring in a reciprocating machine is mitigated through the use of damping springs, so that the entire skid is actually mounted on these dampers rather than being bolted directly to the enclosure as well as directly then to the foundation. So you end up not transferring that vibration back out to the balance of the enclosure and then down to the pad. So it ends up giving you a much quieter, a much more smoothly operating machine than something that might be more directly mounted and then cause vibration throughout the whole entire machine.
Great, thank you, Stephen. How does increasing GGE potential affect the dispenser, hose, breakaway, and fuel nozzle sizing on a newer install or the performance on an existing install? And Dave, maybe you can answer that one.
Yeah, the compression that we have or that we would add to a system through either adding another compressor or the hydraulic does not in itself change the need for dispensing hoses or nozzles. But if you're adding compression and you are maybe changing your vehicle mix or you want to access higher flow, certainly you could look at changing the nozzles and or the hoses, maybe even the dispensers, to meet your vehicle's requirements or your fleet's requirements. But just adding the compression by itself doesn't really change anything. Doesn't require any change.
Okay, thanks, Dave. Do you provide electric motor-driven compressors as well?
Jolene, I can handle that, and most certainly. We actually do, primarily we would be doing electric motors in most cases, and then natural gas-driven engines are available in certain very, very large facilities or in areas where local electrical supplies are limited, such as in the mobile applications or something that would be installed off the traditional electric grid. So we have ability to furnish both.
Great. Excellent. What's the max inlet pressure of the SAFE compressors? Stephen, maybe you can help with that one too.
Yeah, I think I can get that one as well. So the maximum inlet pressure that's accepted in the SAFE unit would be right around 1,000 psi, and that would let us do a two-stage compressor offering a pretty substantial flow rate. So beyond that, we would actually be looking at regulating, but it's usually very uncommon to have more than 1,000 psi available for compression.
Okay, excellent. Thank you. Okay, we've got time for two more questions. CNG compressors operate in a start and stop fashion. Can you explain how you address this in your equipment design? Dave, can you handle that one? Thanks.
Yeah. Multiple starts and stops is a hallmark of the CNG compressors, and it's obviously tough on components. But the SAFE design incorporates a few things to manage that as best as possible. One is the liquid cooling. That keeps the temperatures down in the cylinders. It keeps the temperatures of the equipment down. The heads, the valves, the piping, and all of that manages the material fatigue much better than just air cooling. It also controls the temperature gradients, and again, that helps with material fatigue. And then also just the size. We have the cylinders are liquid cooled, and they also include the pulsation dampening, and so the mass is a lot, and having a lot of mass is also good for resisting wear. Another item is the prelude pump. We have a startup prelude pump which pumps the oil into the compressor block bearings, and just like with a diesel engine, and it keeps the startup wear down to an absolute minimum. And lastly, on the electric side, we have Star Delta starters, which being a mechanical starter, we reduce the input requirements for starting the compressor, but then also mechanical starter is much more tolerant of multiple starts, and we have installations where we've got up to 20 starts an hour. So we're very confident that we do a real good job of managing multiple starts.
Great. Thank you, Dave. Okay, this is the last question. Since the spread between diesel and CNG fuel has tightened, do you see this as impacting CNG fueling adoption in the future?
Jolene, this is Joe. I'll take that question. Undoubtedly, the economic benefit on the delta between diesel and CNG is a driver, but it's not the only driver that people think about when they're considering a fleet conversion. So, there's a rule of thumb that around 40 cents a gallon difference between the two fuels is kind of the tipping point for many fleet applications to consider conversion. And certainly with the shift in commodity prices recently, we're kind of seeing that have a pressure on the outlook for building facilities. But that said, I think many companies that are considering conversion at this point are in many respects forward thinking and realize that the commodity shifts in the market are going to continue to occur over time, and that the spread between the fuels will start to widen, and I would suggest that if you're not thinking about converting to CNG, you may be left behind. And there are again a number of we'll call it social responsibility elements that people think about with the reduction in carbon that comes along with natural gas. And so for those reasons, I do think that the market's going to continue to evolve. There will be some pressure, but there will still be stations developed, and I think through the product lines that we're bringing to the North American market, we are really focused on trying to reduce that per gallon cost to make that equation work, even in an area where the commodity delta is tighter than it has been in the past few years.
Thanks, Joe. Excellent point. Thank you for that answer. This does conclude our webinar today. We're out of time. I'd like to remind you one final time, we will have a virtual pipeline webinar in November. We certainly hope you join us. We look forward to presenting to you then. And again, thank you for your time today. We appreciate it. This does conclude the webinar. On behalf of Broadwind Safe, we hope you have a very wonderful and productive business day today. Thank you. Bye-bye.